Alrighty, next up for our gas laws, we have Charles's law. Um, Charles' law is where we are now having a constant pressure, and we are looking at the relationship of volume and temperature. And this one is different than Boyle's law. This one is directly proportional. So what that means is that they go in the same direction. Okay, the proportions are going to travel in the exact same fashion. So if you have something that is directly proportional, you are going to divide your two variables in order to get a constant. So direct means divide. So if you are looking at changing the temperature of your gas, if the temperature goes up, the volume of the gas is going to go up. It's going to expand. It's going to decrease in density. Okay, if you are going to decrease your temperature, you're going to see the volume of your gas and it is going to contract and increase in density. All right, and this is obviously seen by our hot air balloons. Okay, hot air balloons are going to have air inside a balloon and we are going to heat it up. So if temperature goes up, the volume goes up, and you are going to see that it's going to be less dense. So what is our balloon going to do? It's going to float. Oh, so nicely. All right, but if you want to get down, you basically have to just shut off the hot air. You are going to see the temperature decrease, the volume will decrease, and it will fall, hopefully gently, back down to the ground. So how do we express Charles' law? We express Charles' law with the expression V1 over T1 equals V2 over T2. All right, you can also simplify this because some people complain that they're allergic to fractions, and you can cross multiply it and get V1 times T2 equals V2 times T1. I personally prefer this one. That is what I suggest all my students to do, but some people like to put it into the substituted ones. So if you do put it into the already cross-multiplied one, be very careful that you have a 1, 2, 2, 1 for your labels of all of your different variables. All right, so important things to remember from Charles' law. Okay, when the temperature goes up, the volume goes up. Direct relationship. So V1 over T1 gives you that constant K. I don't know if we're constant K for the Kardashians or what, but that is to represent our constants. Okay, so as we saw with Boyle's law, all volumes must be in the same units. Make sure both sides are both torr, atmospheres, mmHg, millimeters of mercury, or kPa. It doesn't really matter for this law which of those four units you are in, but there is something that is mega, mega important, and that's something that everybody leaves out, or one person usually leaves out a year, and that is your temperatures must be in Kelvin. Why Kelvin? Because you cannot have a denominator where it will be 0. And 0 Celsius is actually quite common. Okay, that's the freezing point of water. So we're going to add 273 to every single number, and then we will get our Kelvin temperature scales. So always make sure that you are not dividing by anything that can go through 0 or be at 0. You are not going to get the correct proportion and obviously not get your answer correct. All right, so one of the favorite videos that I like to show, well, personally that I like to do, is the Crazy Russian Hacker video, what happens if you freeze balloons. So what this is inside this bowl is liquid nitrogen. Liquid nitrogen is negative 195 degrees Celsius. It is very, very cold. So he inflates balloons and then he puts them into a bath of liquid nitrogen. So if the temperature of the balloons is going to go down, the volume of the balloons is going to go down. And you see this shriveled little balloon over here. Then what he does is he takes them out and he puts them on the table. All right, so you have a shrivel balloon over here. The temperature from the liquid nitrogen to the air will increase, so the volume of the balloon will increase, and he will see the balloons magically inflate, but they're not really being inflated, reanimate to their former normal size. Okay, crazy Russian hacker actually puts them in his hands and kind of uses his body temperature to increase the temperature even more. And sometimes they increase in their volume real fast and they pop and he screams. So I totally suggest that you take that out. But you might see Charles Law at work if you have balloons that have been inflated inside an air-conditioned room, and then if you take them out in the summer and they get real hot, so the temperature goes up, the volume goes up, and sometimes they pop. Okay, especially if you leave them in your car. That's really sad. That happens to me. I've also seen them in the winter time, like during the Super Bowl or a winter birthday party, where when you go out to your car in the winter and it's cold, and that means that the temperature went down, so the volume went down, and you think that there's a hole in your balloon, but it's not. All they need to do is to go back into the room where there's heat, and then they puff up, and they end up being a very nice, normal, regular balloon. So sometimes there is not actually a hole in your balloon. All right, a Charles Law sample problem is going to be a sample of nitrogen. It occupies a volume of 350 milliliters at 20 degrees Celsius. Okay, what, question word, new volume will it occupy at 100 degrees Celsius? So again, use the units and the variable and the numbers in order to figure out what your variables are. So a volume of 350, this is going to be V1. 20 degrees Celsius is going to be T1. What volume is unknown, V2, will it occupy at a T2 of 100 degrees Celsius? So let's write that out. V1 equals 350 milliliters. T1 equals 20 degrees Celsius. V2 equals an unknown. T2 equals 100 Celsius. So let's predict. What are we going to see? What happened to the volume? Or what will happen to the volume when we see the temperature go from 20 to 100 degrees Celsius? 20 to 100 degrees Celsius means that the temperature increased. So the volume should also increase because it's directly proportional. All right, before we do anything else though, we have to make sure we are out of Celsius. So add 273 to both numbers. And what do we get? T1 is a temperature of 293 Kelvin, and T2 is a temperature of 373 Kelvin. All right, so let's plug that in. V1 over T1 equals V2 over T2. Kind of fun to say. All right, so plugging that in, we get 350 milliliters over 293 Kelvin. Make sure that you're using the Kelvin one. V2 is unknown, and T2 is 373 Kelvin. How do I get V2 by itself? What's happening to V2? V2 is being divided by 373. So if you want to get rid of fractions, you need to cross multiply and divide. Okay, so sometimes you will see this as V1 over T2 equals V2 over V1 times T2, equals V2 times T1. So what you're doing here is taking 350 milliliters times 373 Kelvin equals 293 Kelvin times V2. Now you solve it the exact same way that you would solve a Boyle's Law problem. Okay, you want V2 by itself. It's being multiplied by 293. So you are going to divide this side by 293 Kelvin. Whatever I do to one side, I do to another in inequality. And you're going to see V2 cancel out, or everything cancel out but V2 on the right-hand side. Kelvin temperatures are going to cancel out on the left-hand side, leaving a volume in milliliters. So how do I put this in the calculator? All right, push pause if you don't have a calculator. Go get one. I'll be here. So in our calculator, we are going to put in everything that we see in the same order. If it's in the numerator, you multiply them. If it's in the denominator, you divide them. So in your calculator, you would put 350 times 373 divided by 293, hitting equals. And our answer is going to be 445.6 milliliters. Does that work with sig figs? We have 3 sig figs here. We have 3 sig figs here. We have 3 sig figs here. I have 4 over here. So my answer is 446 milliliters to agree with my siggy figgies. All right, this is the be all end all answer. Does my answer make sense? Okay, I have a temperature that increases. I should have a volume that increases. 350 is less than 446, so 446 means that the volume went up. Voila! We accurately predicted it. All right, so for students who have notes, you'll see that it's all written out for you. Over here we have our work done as well. CM and D means cross, multiply, and divide in order to get your stuff to cancel out correctly and isolate well. And our answer is 446. So this is Charles' Law.